Beyond the headlines. This is World Insight.
Hello and welcome to World Insight with me, Tian Wei. Over 2 million people have been evacuated and a multi-province emergency mobilization activated as Typhoon Bavi hit China, the strongest typhoon so far this year. Early warnings and mass evacuations have minimized the casualties, and Bavi is now weakening as it moves northwest. But flooding and landslides persist, and so does an even bigger issue. The warming sea are fueling more violent storms. So is this going to be the new normal? Then how do we prepare for what's to come? Let's ask our panelists. Joining us now in Sydney, Australia, Salim H. Ali, Chair from the Department of Geography and Spatial Sciences, Blue and Gold Distinguished Professor of Energy and Environment with the University of Delaware. Also in Beijing, Ma Jun, Director of the Institute of Public and Environmental Affairs. Gentlemen, thank you so much for joining us. Now, there has been increasing talk of what some call the compound extremes and climate whiplashes. We are seeing weather patterns coming from one extreme to another just within even a day's time. So how do we understand this interesting phenomenon, sometimes a really mind-boggling phenomenon? Mr. Ali.
The key is that when we're talking about human risk is calculated using three variables. One is the hazard and the probability of the hazard itself, which, as you have said, is increasing. The probability of typhoons in especially the South China Sea and that whole region is increasing. This is not true all over the world, but in this particular part of the planet, they are increasing. The second is the vulnerability in terms of how much different communities have the ability to adapt. And that's where China has been very positive in its approach to adaptation. So the vulnerability has been reduced because of adaptive strategies. And then the third is the exposure itself, because people are, of course, migrating to the coast in China. We have seen the largest migration by some measures in the last 100 years in the world has happened within China, where people from rural areas in the interior have moved to the coast. So you have much greater exposure. So all those three factors have led to also the perception of, as you're saying, all these extremes that are then impacting people.
Are we more capable than before in predicting about or forecasting about extreme weathers?
In any complex system, you have very high level of unpredictability that is inherent in the system. So for example, I often give an example to my students. When you put milk in coffee, you get all these swirls that form, right? Each time you do that, you have different swirls forming. You cannot predict which swirls will form. So the same happens with complex adaptive systems in weather, which is going to lead to different kinds of phenomena that you cannot completely predict. What you can do is you can look at the different levels of measurements and models. Computer models have improved based on past experience. The models then get new data and they become more attenuated. But you will see when you look at typhoon projections, you have usually 3 or 4 different models which are shown on the screen by meteorologists. And they say, well, this model is predicting the typhoon will go in one direction or another. So a lot depends on which data you feed into the model. We've become better at it, but we are still limited to about 2 weeks. We cannot go beyond 2 weeks of prediction with any level of accuracy. Now, that's different from long-range climate change, where you average the trends and you see whether long-term projections are changing. We are better at that, surprisingly, than we are at the short term. And that has to do with the law of averages, because the averages eventually give you trends which you can then predict with greater accuracy.
May I ask you a bit further on that? You talk about the data that would help the human being now to do the forecast, the 2 weeks ahead, that's the most we could do. But to what extent can we collect the data from the past? In other words, with how much data are we working with, worldwide speaking? I think this is a joint effort globally.
Absolutely, yes. And some of the kinds of data that we previously were not capturing, we are beginning to capture at a higher resolution. So moisture content of the atmosphere, the way even the surface of the ocean, we are putting in data in terms of the different kinds of surface factors which can impact how storms form. So all of that is getting these models better at predicting. And with supercomputers also, we have much greater capacity to process the data. And China has been clearly a leader in that. Now, AI can play a role also then in helping to manipulate and understand which data is more useful. And so all of this coming together, it is possible that in the future we may be able to have a higher range of predictability.
But Professor, how long in history, in the past, can we collect those data? Because I don't know, globally speaking, how are those data being put together? How are they being shared? How are they being, ever more sharpened, so to speak, in order to fit into the cause?
We cannot collect it going too much far in the past for two reasons. One is the data was just not there as much. In the 1960s, we started collecting global environmental change data through an international agreement. There's an institute in Austria called the Institute for Applied Systems Analysis, which was an amazing initiative where countries from all over the world got together and they said, we will share data on global environmental change. Even the former Soviet Union and the Americans agreed to share that kind of data. But the other factor why we cannot do it because we don't have before 1960s, because the past is not going to be the same as the future.
Right.
So even if we had the data, if we go too far in the past, it won't be helpful.
But over the past several decades, Professor, the weather has been evolving, and yet when it comes to weather patterns, one could argue it's such a short period of time. When it comes to spatial sciences, I mean, for a few decades' time, it's a big drop of water in the ocean. So does it really help us to predict the weather patterns? To what extent do you think you are satisfied as a scientist about that capability of forecast? From 0 to 100%, where are we to you?
Yeah, we are definitely quite far from 100%. I think we are above 50%, between 50 and 100. But the challenge is right now, the global connections between weather systems also are not fully understood. So, for example, when we have what we call the El Nino effect, which is a warming of the Pacific Ocean at a certain point that is related to multiple factors, astronomical factors, as well as geological factors, that can have an impact in China thousands of miles away, right? So those localized changes and how they impact external weather, we are still beginning to follow and understand that. So that's why I'm saying it's still, we're in a learning phase, we're getting better, but we remain hopeful.
How Chinese scientists and weather bureaus have been doing their job in forecasting, and this time particularly, I think the warning has been given out very early, and it seems that localities are quite well prepared, but things are always changing because we're talking about a typhoon. It is always moving, not like predicted. So tell us more about your observations.
Last year, I was invited to visit the China Central Meteorological Bureau, and the chief meteorological forecaster told us personally in person that she used to be to do all this forecast based on her own research and of course based on their own analysis. And now increasingly they're trying to tap into the power of AI, and encouragingly the forecast made based on AI is getting increasingly more accurate. So that brings hope. But as mentioned by the professor, the forecast is never, easy. This time, the route of Bavi is, the forecast of that have been changed quite a few times. And not just the whole route, but the landfall. And also, when it pushed inland, much of that forecast is accurate. But this time, we're seeing, these typhoons not going directly northward and got stuck like some previous typhoon in the North China Plain, by the geographical formation and also by the weather pattern. So that's in some way it's quite lucky. Otherwise, it will bring much heavier rainfall, downpour in this region.
How much preparation will get us really prepared? How much is self-comforting? And how much is really prepared for the extremes?
Yes, I think we are constantly in a struggle with trying to control nature, and there are limits to what humans can do in terms of controlling natural systems. I think what we have to do is evolve with nature as a species, as we have done historically as well, and that requires a certain degree of humility. We have to recognize that there will be times when we will not be able to have that level of control. And then we will need to be able to have the resilience to build back. And that has to be part of the psyche of how we teach our children, how we work through our educational system so that they have more forbearance.
This is so crucial, not to be afraid of the facts. That's one of the key issues we should learn in history, isn't it, Mr. Ma?
Yes, exactly. And I think to add on that, we still need to tap into the new technology to continue, investing in this AI-driven and hyper-local meteorological forecasting, and try to complete the mapping of the disaster-prone, some blind spots in the hilly regions in China. And in the meantime, particularly the North China have to be more prepared, because we do, observed a changing weather pattern, for rainbelt to move further deep into the north and western part of China.
Mr. Ma, if I could, I would love to let you explain more about how the sponge works in China. I know that you have several case studies to share with us, but can you maybe briefly tell us how it works? And has that been tested over time? Does it work?
Yeah, for many years, China's going through decades of urbanization, and during the process, much of some of the natural buffer zones have been occupied, and the city have been paved up, so make it very difficult for the rainfalls to penetrate into the soil, and in the meantime, many rivers and lakes have been reclaimed for urbanization, either for residential use or for industrial use. And because of that, we're losing all this capacity. So the whole idea of sponge city is to make our city, more resilient by returning some of those occupied, paved up zones to nature. China have this whole program rolled out to return, all this land to lakes, for example, to restore some of the lakes and some of the rivers and canals and channels in the cities. And in the meantime, for example, when we try to do all this landscaping, greening of our city, instead of building a elevated one, we're trying to build that more, at the lower, in those lower regions, so that it can naturally absorb all this flash flooding, and also making our paved areas more, using more new material to try to make sure that the rainfalls can penetrate.
What about those important climate phenomena? For example, the Arctic warming, for example, El Nino. How much of those phenomena are having an impact on what we know, the changes of weather patterns going on here in China and elsewhere in the world? Can we really, shall we say, draw a link between them, or that link is not necessarily that clear?
Yeah, when you look at long-term phenomena, it is 100% interconnected. When you look at short-term phenomena, that percentage changes and is reduced because you have more localized events. So, for example, the Arctic warming, what we have in Greenland or in Svalbard, that is going to have an impact in the long run because that melting ice is going to, of course, change the temperature of the water. It's also going to expand the water in terms of higher temperatures, and that will lead to changes in sea level that will impact everyone. It will also change, as Mr. Ma was noting, the moisture content of the atmosphere, and so we will get all those changes. That is why China has a research station in Svalbard and is very interested in the Arctic because it realizes that from a studies perspective and also an impact perspective, it can have consequences. In the short term, effects are more localized, and then they need to be managed more at a local level. So I think we need a bit of both. The old aphorism, we would say, think globally, act locally. So I think that's what we need to follow, but it's more complicated. We have to multitask. We have to think globally, we have to act locally, and we have to think locally as well.
What about El Nino, another climate, shall we say, phenomenon? It is impacting in many parts of the world. Does that have much to do with what is going on right now in China?
Yes, that has the most direct impact in terms of the typhoons because the Pacific Ocean basin itself is impacted when you have a warming of the Pacific. And of course, the Pacific is the main ocean that is bordering China through its subsidiary seas. And so the El Nino is a much more proximate impact compared to the long-term impacts of Arctic melting and the Antarctic changes and so on and so forth.
What about the bigger climate patterns, about climate warming, about Arctic warming, and about El Nino? Your thoughts on that?
And now this year it's being developed in some areas faster than expected, and this is it has a lot to do with the weather pattern variation in this part of the world. So based on all this forecast, the Chinese meteorologist announced at the beginning of this year that there will be two rainy belts, one in the south, one in the north, and now that has been proved by the reality. So it proved that El Nino is having its impact. And in the meantime, we are seeing, another big weather system, which is the subtropical high. This subtropical high this year come to the north much earlier, and in the meantime, much stronger and stay here quite in a stable way. It acts like not just as a steering wheel, which guide all this more typhoons to come to deep into even North China or Northeast China. But in the meantime, it will also pump all this water moisture, from the very warm, South China Sea, and also from the big ocean into the inland China. So that brings, and in the west, in the northern part of China this year, we are experiencing more so-called northeastern cold vortex, or the cold front. And so when the cold weather meet with the with all this warm weather with a lot of water moisture, it will bring not just heavy rainfall, but also more convective weather events. So we are experiencing more thunderstorms and even gales and hails in this region. And behind that, over the in the long term, it all in some way have something to do with a big backdrop of climate change.
I understand, Mr. Ma, China has been making tremendous efforts to use clean energy. If you look at the cars running on the street, they're very quiet. One of the reasons why they're quiet is because they are electric cars. So how much do these efforts really help in a micro way? And how much efforts have to be made in micro ways so that it would eventually macroly help with the situation?
Yeah, when it comes to climate change, there are two major events. One is adaptation. We talked about how it is happening, like it or not, and we are not, gaining enough speed and scale in our carbon reduction. So as a result, the temperature continues to rise and more frequent weather, extreme weather events. So we must be adapted to that. And on that, there are efforts made, but it's still not enough. We haven't seen many Chinese cities making very detailed, for example, the detailed mapping of the potential, vulnerability of our cities. So with that, we need to learn from cities of London or Paris or Sydney. And on the other hand, the real solution got to be mitigation, meaning we must try to reduce and eventually neutralize all this greenhouse gas emission. And China, still the largest current greenhouse gas emitter, have done massive efforts to try to not just cut the emission directly of carbon dioxide, but also try to expand to conduct a total transformation of our energy supply. With that, the renewable energy expansion is mind-boggling. And for the first time, the proportion of China's installation capacity of wind and solar is getting bigger than the capacity of fossil fuel power generation. So that brings a lot of hope. And now, China's number one in not just in all the installation of all this renewable capacity, but also the largest supplier of all this equipment. On the electric vehicle side, China has now has more than 40 million electric vehicles running in the street, and the market penetration is pushing from 50% to 60%, and that's absolutely is very helpful.
Professor Ali, how do you see the China practice, and meanwhile, how the world should tap into the latest technological changes and take advantage of that to make sure there will be less emissions, as we all know, which will be harmful for our environment? Do you think we're doing it, or are we acting on it, or are we just preaching about it?
I think we are doing a good job with the technological transition, but we also have to keep an eye on our total consumption and resource usage. Because even if we switch completely to electric cars and we continue to consume more, we will end up in still a very difficult situation. So I think especially for the developing world, it's very important that we set a different model for consumption. If everyone started to live the kind of lifestyles that the American household lives, we won't be able to sustain the electric car prevalence, even if we wanted to, because we won't have enough materials to provide that for the whole planet. So we have to also reduce the overall consumption. And that's where I think Asia has set a very good example, all of Asia. China, Japan, Singapore, all these countries have very high quality of life, but lower consumption per person. So I think that has to be kept, whether that's using public transport, whether it's biking more, whether it's walking more, designing our cities so you do not need as many cars. That always has to be our ultimate goal.
Yeah, as absolutely as mentioned, we need to make more better preparedness and based on all this more accurate forecast. And in the meantime, trying to build all this infrastructure to be ready for extreme weather events. And in the meantime, we need to make sure that all our city management, they can, they gain the whole awareness that things are changing, and they cannot only, be prepared based on their own experience in the past. They must be prepared for this new reality, with a big drop of increasing extreme weather events.
Ma Jun and Salim H. Ali, thank you so much, gentlemen, for joining us. And that is all the time we have for today. If you'd like to know more, search World Insight. Check out our YouTube channel. Follow us on X and Facebook. I'm Tian Wei. Thank you for being with me. Bye for now.